Hello friends, today we are solving this problem, maximum number of events that can be attended to. So guys, we are not only just solving, which is already a lot of solutions are there, but the point here is we have to make the intuition that how to solve these problems, how to reach for those solutions. So we will build that intuition, then step by step we will be solving it. So let's read the question first. So we are given an array of events like this, that it has the start day and end day and the value I, that if we attend this event, we have to be inside the event from start day till end day, so we cannot skip it, we have to stay. And the ith event start day I and end at end day, so we achieve this value I. So you can visualize here like this. Suppose these are the values, these are the events, and there is an integer k is also given to us. Means a person can attend maximum up to k meetings, not more than that. So what we have to do is we have to find that what would be the maximum amount that we can achieve, because this is the value. If we attend a meeting, the third element is actually the value we will obtain here. So for example, here k equal to 2. So what we will be achieving if we attend these meetings? So we have to attend only 2 of them. Now these 2 meetings, whatever k meetings, those meetings, first of all, they should not be overlapped, right? So see here, this is starting at 1 and ending at 2. So what we will get from here? We will get 3 from here. Similarly, if this is also starting at 3 and ending at 4, so it is not overlapping with it. It's ended at 2 and it started at 3. So what value we can attain? We can get 8 from here. Similarly, this is also not overlapping with any one of them, so we will get 10 value from here, but we can take only 2 of them, right? So this would be giving us maximum value, that if we attend the second one and third one, we will get the 18 total sum. So this would be the max value. So this is very simple use case that we are attending. Now we have to change a bit for these use cases. Okay, so we are going with very simple plain approach, then we will go for any final conclusion that how to solve overall things. So for example, let's say instead of this 3, I'm making it 2. Okay, so I'm making it 2. Now look at the meeting 1 and 2. Is there overlap? Because it is ending at 2 and it is starting at 2. So in the question it is given that is also would be considered as overlap. Okay, you can see here, note that the end day is inclusive, that is you cannot attend 2 events where one of them start and other one ends, right? So same thing is happening here. See, this one is ending at 2 and this one is starting at 2. So these are considered as overlap, so we cannot consecutively attend these 2 meetings. Okay, so what will happen then? Only one of them we have to attend here, right? So maybe if we attend this one, we will get 3. If we attend this one, we will get 8. So it looks like we should get 8, right? With the plain mind, it's only one of them if we can attend. Let's take this one, we will get more value. Okay, for now let's consider 8, and here we will, this is not overlapping at all, so 10 from here. So again we will getting 18. Well and good, we are still getting 18. But let me change a bit again. Okay, so suppose here what I'm making, let me make here this 5, instead of 5 let me make it 4. Okay, now what will happen? These both of them are overlapping because it is ending at 2, this is starting at 2, so only one of them we can take, right? So with our greed, what we did, that okay, if one of them we can take, let's take this one. Okay, let's take again this one. So we are getting the value 8 here. Now we are hoping that we did some good thing, because we are getting here 8 with the local greed. So now we are coming to here, that okay, what we will get from here? We will get 10 from here, but wait a minute, this is ending at 4 and starting at 4. So they are overlapping. So if they are overlapping, we cannot pick, we cannot attend, right? So in this case what we are getting? We are getting only 8 because of this greed, that I will get 8, right? So greed. Now what could be a better approach? Instead of picking this one, if we would pick this guy, right? Because only one of them we will pick, so we will pick this guy, so we will achieve 3 here. right? And this is not overlapping with this third one, so we will get 10 here. So 10 plus 3, this is we are getting 13. So what I mean to say is this local greed will not work here, that if this is giving me more, this might lead for a better answer. No, not always. So we cannot make this as an our assumption here. So greed will not work, right? So we don't know that which one would be lead to a best answer. Okay, so what I mean to say is we are not using any greedy approach. Then what to use? So we don't know because greed is not working here. That means first of all we can pick the meetings which are not overlapping. If they are overlapping, only one of them can be picked, right? And also we have to take only the k events, right? So there could be huge number of values, but only k of them we have to take. So in this case, what we have a conclusion, it looks like the way which we do in the dynamic programming, that we are picking a meeting or we are not picking a meeting. Same, let me pick and do the solution, or let me don't pick this and go for the next. So in this way, what will happen, we have to take 2-3 cases. Number one is we have to either pick a meeting or not pick a meeting. Number two is we have to take care that we can take only up to k meetings. So with this intuition, let me take a better example. In the question, it is nowhere given that these values are, they can be random, right? They need not to be sorted. So on the start time, we have to sort it. Now you might have a question that why on start time? What is the use of it? The use of it is, for example, let's say if we are starting from here, this is event 1, right? If we are starting from event 1, why do we need to sort them based upon the start time? That is a question. So it is starting at 1. Now if we want to check this starting at 1 and ending at 2, if we want to check that who all are overlapping, then we have to take this guy and we have to look in this entire thing, right? That who could be the overlapping, then we will come to know here, right? So in this case, what will happen, every time for this guy we are taking n, right? For other guy also we are taking n. So n plus n plus n time, it would become n square, right? So instead of going for n square, let's sort based upon that start time, so that in on n log n itself we can do that thing, right? So that is the reason why do we need to start, we have to sort it based upon the start time, right? So this is 1, then second value should come this guy instead of checking everywhere. So that is why we are sorting it based upon start time. So let me rewrite it in the sorted based upon the start time. What I have done is I have sorted based upon the start time. You can see 1, 2, 3, 5, 6, right? Now let's say our k is equal to 3. Okay, now we have to pick 3 out of these, right? So that we can have the maximum value. So let's build the intuition that how do we come for any approach. Let's say we are starting with this, right? If we start with very first one, we are starting from here, right? Then we will check that which is the next event that we can pick, right? Let's say if we pick, then okay, this is the what it is happening. There is an overlap, right? This is ending at 2, this is starting at 2. So we cannot pick. If we are starting with this guy, we cannot pick this one. Okay, so let's look what is the next valid value. Is this one is overlapping? No, this is not overlapping. Then we can pick, right? Now at this location we have to look what could be the next, because so far we have found 2 and k is 3, so we need one more. So can we pick this guy? No, we cannot pick because this is also overlapping. Okay, then if we cannot pick, can we pick this guy, right? So we can pick because this is not overlapping. So for this, if we start from here, we can pick this guy and also we can pick this guy, and 3 is the needed. We cannot go more than that. So you can see here we are getting 3 plus 8 plus 10, right? So this would be 20. Now it's not guaranteed that this would be the best answer. So as we assumed, right, that if we don't pick, let's say I'm not starting with this, because who knows, we can get a better answer when we start from this one. So okay, let's start with this one. So can we take this one as next? No, because these are overlapping. You can see here this is ending at 4, but this is starting at 3 itself, so they are overlapping. We cannot pick together, right? Then okay, let's look which is the next legit. Can we pick this guy? Yes, we can pick this. Okay, now we are at here, so can we pick this guy? No, they are also overlapping. we cannot pick, right? Because it is ending at 7 but it is started at 6, so we cannot pick like this. So we have multiple options, as we initially said. So at every location we can either include it or not include it, right? This would be the concept here. So based upon this, so far things should be clear. Now let's go ahead for this. First of all, we should be very clear that if k equal to 0, right, if k equal to 0, there should be answer also should be 0, because if we are not picking any event, there would be 0, right? So we can directly say, we can go ahead with this assumption that in case if k equal to 0, our answer would be 0, right? Because we are not picking any event. Or when we are picking the events, right, see, we are starting from here 0 till n minus 1, right, if its length is n. So in case we are reaching to any location where our current index is n, at that time also we should return 0, because there is no more event. When we are reaching till n minus 1, only the events. If we are reaching to n, that means there is no event, so that is also returning 0. We should be very clear with these points. Okay, now what is the use of all of them? Now we will write a recursive approach now, because we have the closing conditions and we have to find that how we can go ahead with the recursive approach, right? So in the recursive approach, we have this closing condition, right? If you can consider if k equal to somehow become 0, okay, if k equal to 0, then, or if current index, let's say we are starting with the index, so let's say we are calling it current index. So if current index reach till n, then also we have to return what? We have to return 0, right? So k equal to 0 or k equal to 0, we have to return answer should be 0. This should be observable. Now what we have to do for every index, what we are doing, either we are including it, let's say I am calling it include, either we are including it a meeting. So if we include a meeting, what will happen? We will get this value, right? Let's say we started with the current index, okay, so we will write it. So this is our first closing condition. If this happens, we have to return 0, otherwise we are starting. So we can have either inclusion or we can have either exclusion, right? So for index curve, we started, let's say we started an index curve, okay. So curve initially we will definitely call it 0, but consider in general that we are at any curve index, and this curve index, if we include it, what value we will get? Whatever is the value sitting at that index with this third value, right? So that we will directly get. So let's say on the event array, on the index curve, we are definitely getting the third value as the value, right? Because including it, curve and the 2, right? So this is the value, this third guy which is sitting at index 2, this would be directly value we are getting because we are including this curve. For example, curve is here, or in general anywhere you can understand. Then if we have taken this guy once, our k, what will happen to our k? Our k would be decreased by 1, right? Because 1k we have picked here, right? So we are putting this, and whatever function we are calling it, that function we have to again call on the remaining things. So what will happen? Our k would become what? K minus 1, right? Our k would become k minus 1, and we have to find the next legit thing, right? So we have to find next legit value, like here when we are at here, what would be the next legit meeting? So this was not next legit because it was overlapping. We found this as the next legit meeting, right? So one way is just one by one go to right side and look for which one is not overlapping, right? If I go from here at this curve, if I keep on start checking from here to right side, I can easily find that okay, this one is the legit one because this is not overlapping. But this is not a efficient way, because every time we would again end up like n plus n plus n. Then what to do? Now you can observe, because start time is sorted, right? 3, 5, 6. So on such kind of things we can use the binary search, right? So we can write a binary search function which will find that which one is the next legit value, right, to find for any cur index, right. So because here we are including this cur, so our k would become k minus 1, okay, and then we are looking for the next legit index, right. Our cur would be next legit cur. Like in this case, if this was 0, next legit would be this would be 2, right, next index which is legit. So I can call it next cur, okay, that we got from the binary search. So this would be our next cur, right. And if we don't include it, that means we are excluding it. So if we are excluding, that means we are not taking this value at all, this event cur to this value we are not picking at all. In that case, what will happen? Our k would be still same because we haven't picked it. So k would be still same, and whatever is the cur value we are making just for cur plus 1, because we are skipping the previous one. So we are looking for the next guy. So this is the inclusion, this is the exclusion. Now whoever is giving us the maximum value, that we have to return, okay. So return max of exclusion and inclusion, right. So you would have got the basic idea of this recursive approach, right. So we can write it here, maximum of inclusion and the exclusion. So with this approach we can write the memoization approach as well, right. So I will show you my corresponding code for it, and once we understood with this memoization recursive approach, then we will also go for the tabulation approach, which is final best approach, right. But without this we cannot directly go for it. So let me show you my corresponding code for it. So you can see I have both submission, but let's look for the this one, the one which is using the memoization approach. Okay, so I am putting it to my editor, and see here what we are doing. So first of all, this is our I have created one DP for the memoization. So this is of k plus 1 size and n. Why k plus 1? Because it is starting from 0, so we want to keep the k values as well, right. If we create only k, then it would go up to k minus 1, but k can go up to exact k, right. So for that reason we are making k plus 1, and n is the size of this event. So we created this DP array for the memoization purpose. Now initially I am putting every value as minus 1 in this DP array. Okay, now see here we have written this util method. Okay, what this util method is doing, it has like events array, the array which is given in the question. This is k and this is the current index. Basically we will start from 0. Now same thing, if k equal to 0, that means we are not picking any event, or this cur reached till n, right. After n minus 1 next comes n, right. That means we are already overflown. In those cases it should return 0. So this is our closing condition, right. And this is our condition that if we have something already filled in k cur, dp k cur, that means it is not minus 1. So we can return that as answer, right, because dp was already filled with minus 1, and if we have some value, that means we have solved it. So we are returning it directly. Now what we are doing here is, see, you can visualize we did this inclusion and exclusion, right. So same fundamental would be come to the picture. Now see here, this is our next index for any cur event. See here, when we were at here at very first, we were finding the next cur legit event. So we found this one, right. This one is the legit event. So we are using binary search instead of searching it one by one, because binary search should be optimized, because these start times are already sorted. For that reason I am doing. So see here, we are using next index equal to get next. So this get next is nothing but just a simple binary search. Okay, you can visualize here that on this event array, and this end day. End day is what? So what we are passing here, this is the end day, right. Now we have to find the event in the right side whose start time is greater than this end day. Then only we will get the, so you can see here when we this is the end day, so this guy is starting, so this is overlapping, but 3 is greater than the end day, so this is the start time. So this is the legit index for us. So same thing what we are doing here is we have written this get next method. We are passing events and the end day of that current index. So this get next method, on any current index we have to pass the end day of it, and then we are finding the value, right, like the meetings on the right side, which is not the overlapping one. Okay, so for that reason I have written this get next. You can simply see here, this is simply a binary search. We are taking left equal to 0 and right this, while left is less than right, we are getting the mid. And if this is the case, like if end day is still greater than the start of it, we are making left equal to mid plus 1. Basically we are going to the right side further because it's overlapping. Otherwise we are making right equal to mid, we are going to the left side. So this left would be the nearest one, which is non-overlapping. We are returning that index. Now what we are doing is, whenever we are calling this function on any current index, first of all we are coming here, we are getting the next legit index where the meeting resides with non-overlapping stuff. Okay, now we have written two values here. See here, this is include and this is exclude. So include is like if we are picking that current value, then we are adding the value because we are picking this cur meeting. So whatever is the meeting value that we are taking from here, just like we did this 3, because this is sitting at index 2. So we are adding that, and we are calling again this util function on event and k minus 1. We have, because we have picked one event, so we are decreasing it k by 1, and we got this next index, right? So this same method now would be called at this place, right? Because this was the our next legit guy. So same thing is happening in my this memoization code. See here, we have called it again. So this was when we are including the current one. If we are excluding it, then what is happening? K is keeping as it is, but I am going for the next index, cur plus 1, right? So we got this include and exclude, and whoever is giving us the maximum value, we are assigning that to this dpk cur, right? Okay, and finally we are returning this dpk cur. This would be our answer. So let me execute this code. So I am running this code. Yeah, so I have already submitted, but it is not the best answer, because see, it is only beating 28%, right? 11%. Then that means why this is not faster? Because we are using the recursive approach. Even though we are using the memoization, but still we are not using the tabulation approach here. So what happens is, in the case of recursion, it internally creates the stack calls, which makes the performance slower. So for that reason, with the same concept, we can do it with the tabulation approach. So I will show you my tabulation approach also. So which is, yeah, this one is my tabulation approach. So let me load this code, and this has same fundamental, that is tabulation approach. So what we are doing is same fundamental, but you can observe here why we are making dp equal to k plus 1 and n plus 1 here, because we are making a tabulation thing, right? So we have to go till 0 to n and 0 to k. So for that reason we created this dp. Okay, now we are sorting it based upon start time here, same way, the way which we did there. Now what we are doing here is, so we are starting for j equal to n minus 1. Okay, and j greater than 0, j minus minus. So same method we are still using, get next index, right? Because every index we have to find the next legit value. Now you guys wondering that where is this, we have written this closing condition as well, right? If k equal to 0 or cur equal to n, then return 0. So you can see here, this code is written in Java, and whenever we are creating, the by default values would be 0. So we don't have to explicitly store the values where n or where k equal to 0. We don't have to explicitly write 0, because by default those values are 0. So that is why this case is automatically being handled. Okay, so you can consider dp 0 where k is 0 and where it is equal to n, those values would be automatically having 0. So that is why we are starting from j equal to n minus 1. So basically this is bottom up approach. So we are starting from j equal to, this is like cur, equivalent to cur, and greater than equal to 0, j minus minus. First of all we are getting the legit next index, right? Same function I am using, I didn't change anything. This will give me the next legit meeting. Okay, so we are calling this we are passing the current end time. Okay, so now what we are doing, we are also going from for I equal to 1 to I less than k, I plus plus. Now you might have again a question that why I equal to 1, why not I equal to 0? Because at k equal to 0, I equal to 0 is already taken, right? When we create it, it has already the value 0, which is given as like in closing condition. So we don't have to explicitly write it. So we are starting from I equal to 1. So see here, I have calculated this next index at this step itself, because these are our current index and this max matter here. So we need not to call it inside it, though we will use it inside only, so that we can avoid some recalculation. Now inside it, same fundamental we are using here. If we are including, then what we are doing on current j, right? J is the current index, so we are adding that value, the third value, which is basically value, and then we are making this I equal to I minus 1, because I is now our k, right? In the recursion we use k, so here we are making I minus 1, because you know in the DP, in dynamic programming, we split the values to smaller chunks, right? So for that reason, and this is our next index. So these values would be include, and if we exclude, that means what we are doing, we don't want to go ahead with this j. So what we are doing, we are just passing it for the next variable. So dpi j plus 1. So see here, we are making j plus 1. So when we started j equal to n minus 1, here it would become n, and you know at n it is already calculated the value as 0. So that is why we call it bottom up approach. So we found the include and exclude both, and then we are filling the whoever is the maximum, that will go for dpij, right? So in this way, once we are done, we would be reaching till 0, okay, and this would be reached till k, this I would reach till k. So finally our answer would be residing at dpk and starting at 0, right? We reach till 0, so dpk 0 would be returning our answer. So let me execute this code. So I am running, I have already submitted, right? So what is the time complexity here? So we are sorting, first of all we sorted this event, so n log n was captured here, and here we are taking like n and k, right? This is running n times and this is running k times, so n into k, so it would be n into k plus n log n. That would be the time complexity. Similarly, space complexity would be also n into k, because see here, this is the extra space that we are creating. So now you guys should be clear, but still I would be suggest take your pen and paper, do some brainstorming around it, and then write the code. So thank you for watching this video, and also those guys who need this code, the one which I have explained, I am putting it into the comment section, you can copy it. So thank you for watching this video, and if you guys have any concern, please make a comment over there. Thank you.